and just completely fell in love with this idea of people, planet, profit, doing things that I love, and just taking power out of the grid, making things more efficient. I'm working towards things that my kids and grandkids will benefit from.
Zone. I'm Doug Davenport, the founder, executive director of Prospect Silicon Valley. This is People of Prospect. This is where we have a half-hour conversation with an interesting person in our ecosystem. And I'm really excited to introduce to you this afternoon, Bob French, the chief evangelist for 75F, which is a very novel smart buildings and energy efficiency technology company. Bob, how are you doing this morning?
I'm doing great. The afternoon just started here in the central time zone, so you're spot on.
And you're in Minnesota, correct?
In Minnesota.
So you're not drinking coffee because it's afternoon. I'm still having my my hairbender it's literally called Hairbender from Seattle.
Well, actually, it is afternoon, so I'm starting off with a cider. I am a ciderist, and I've been making cider for over 20 years, and I've kind of gone down. Yeah, I make my own, and I've gone down a deep rabbit hole. So, last week I was out collecting budwood for grafting the types of apples that I want to pick from 5 years from now, that I will harvest, then and turn into juice and wait for a year and turn it into cider. I do about 100 gallons a year. So it's just an advocation, but I love to share it. I can't drink 100 gallons a year myself. So it's all about sharing it with my friends, which I love to do. And it takes all year. There's something to do all year long with cider making.
Ladies and gentlemen, Johnny Appleseed. Thank you. No, that's really cool. Well, let's get to the topic at hand, which is 75F. You're the chief evangelist, and so maybe let's just tell people about 75F and what it is, what problem that 75F is solving in the buildings market.
Yeah, so first, I just want to mention, most people on this call may recognize Breakthrough Energy Ventures. It's a Silicon Valley VC. We are backed by BEV and OGCI, which is the Oil and Gas Climate Initiative, for our new high-tech platform. So we're a tech company that is essentially building the next generation of building management systems. BMS would be the term generally used. The last time such a thing was done was over 20 years ago with Niagara. And so we are an IoT BMS, which is, the modern way that IT people would solve this problem. Namely, that is the idea of removing the on-premise server layer from the BMS and putting it up in the cloud. And then, of course, there's just a ton of benefits that come with that kind of architecture. It's a completely new way of doing a building management system. So, once you have the server layer up in the cloud, there's these things that you can do that a traditional BMS just couldn't. I mean, cloud computing is just capable of doing things that on-premise computers just can't. And I'm sure you've heard of machine learning, artificial intelligence, all these things. Once you get unlimited storage capacity in the cloud and unlimited processing capability, you can use techniques like machine learning to figure out what the pattern of the building is. And instead of reacting to the needs of the building as it changed throughout the day, looking at these patterns and predicting what's going to happen and being proactive. That's a completely new way of automating HVAC and lighting controls.
And that's really interesting. So I'm going to ask you a question, but I'm going to tell you a story. Okay?
Sure.
A very successful particle physicist who was a student of Enrico Fermi and literally co-wrote a book with Enrico Fermi, whose work literally resulted in the first nuclear reactor in the world, decided that particle physics wasn't a noble enough cause and got fascinated with buildings and created the practice of building energy efficiency. Now, I tell you that to maybe people that are in this audience to appreciate that buildings are really complicated. It literally took a particle physicist working with one of the greatest minds in the world to decide that buildings was a big enough scientific matter to tackle it and create energy efficiency, right?
I love that.
So what is 75F doing to kind of tap into all the complexity that actually happens in a building to create this kind of cloud service? You make it sound so easy when it just comes to this pattern, and we're going to find these patterns. Talk about the complexity that buildings really, really carry.
Well, before we get into the complexity of the building, and I appreciate that story because, our buildings are consuming about 10% of the energy that we produce in this world, which is a fantastically huge number, right? And so it is so worthwhile. I mean, there's lots of people really focusing on power generation, alternative energy, and those are really important things to advance in clean tech. But on the consumption side, the demand side, right, we're electrifying our cars. We are changing the way the power is generated. But when it comes to consumption, buildings are next, right? They're the next thing as far as the target in terms of reducing our energy consumption and the CO2 output that we are putting into our planet. So it's a very, very noble cause, and it gets me up every day. I haven't worked for many, many years because I'm pursuing my passion, right? I don't feel like I'm working at all. So getting to your answer though, buildings are very complex because obviously you have a daily cycle that occurs, right? Solar gain, starts off in the east and moves, over to the west side. This creates a very dynamic environment in a building. Most commercial office buildings have substantial windows, and so solar gain is a huge factor that will change the heating and ventilation requirements on the east side versus the west side in the morning and throughout the day. And then with commercial buildings too, there's the zones that are in the perimeter versus those that are in the core. Right. So a building just by existing and being turned on creates heat. So the core spaces are always wanting to get cooling, whereas the perimeter spaces, depending on the time of the day, where in the world it's located, what the weather is like, it could be needing cooling or heating, but usually it's a combination of both depending on what time of the day it is. Right. So, and I'm sure you can appreciate how complex just those two factors are. We're talking about a multi-factor polynomial here. And then change, the occupancy, change the preferences of the people in each space, change one floor versus another floor in terms of how it's all laid out, in terms of open office spaces versus compartmentalized spaces. So you can see how this, just exponentially gets more complicated very, very quickly.
Yeah, it is really fascinating that buildings in and of themselves are really complex systems, and you put people inside and they become almost an organism, right?
Yeah, that's right.
So 75F is really in one way really helping tie together the disparate systems of a building beyond what a conventional BMS would do, and allowing for a far greater, net efficiency as a result. Is that fair to say?
Yeah, that's fair to say. And I do want to point out too, and I mentioned earlier that we've taken the on-premise server layer out to the cloud, but that doesn't mean that the controllers and the supervisors are in the cloud, because that's not true. It's really a hybrid, because we have giant air handlers and chillers and boilers and the things that we have to have operating in the building. We can't have their operation tied to something that's up in the cloud, right? The reliability of that, as good as it is these days, is not good enough for that task, and it may never be. We'll see. It's a hybrid, so that means that the supervisors and controllers, the things that are making the minute-by-minute decisions, are resident in traditional hardware devices that are located throughout the building. And I mentioned earlier that it's an IoT design, Internet of Things. Obviously, that's a buzzword. It's been going around for over 10 years.
Right.
But it essentially means the use of many devices with many sensors that pass their data up to the internet. So we put probably 10 times more sensors in a building than a traditional BMS does. We do this because the IoT architecture just lends itself to that, doing it very efficiently, right? The storage capability in the cloud. We use a wireless mesh network inside of the building, for example, instead of traditional networking. So we've broken down those barriers to getting that data, very rapidly up into the cloud. So those factors, come into play.
You're working with a group that's really getting into the deep technical details of connecting with every little tiny bit of a building, this organism, as we're calling it. And that changes throughout the day and changes whoever's in it, et cetera, et cetera. And so there's a lot of really heavy technical stuff. But at the end of the day, your heart and your sensibilities in this is that, there's a global impact to what you're doing. And I thought maybe you could share a bit about how you got into this field and what sustainable buildings means to you personally.
Actually, that goes all the way back to my high school days. Back in the 1970s, I know I'm dating myself, but it is what it is. I was in high school and we built a solar heated home. And I became just fascinated in solar power. As I was thinking about college, I had a plan A and a plan B. And plan A was to get an appointment to the U.S. Naval Academy at Annapolis. And in case I didn't make that, my plan B was to go to NMSU and study solar power. And that was my choice at the time. So I got my appointment and I ended up going down that path. And it took me away from what's now termed as clean tech. So as I went down that path, I always had in the back of my mind, my interest and love in clean tech. And so when I got into my 50s, I was just in a position to pick and choose a little more carefully the kinds of career choices. And I got into clean tech in 2012 and just completely fell in love with this idea of people, planet, profit. This idea that I could be getting up every morning and not going to work, but just doing things that I love, just taking power out of the grid, making things more efficient. It's just a love that I had. I had, starting, I guess, in the late 90s, started working with the University of Minnesota and became an entrepreneur in residence because I had started several high-tech companies by that time. And so those people are mentors to contestants in the Minnesota Cup, which is a big statewide business plan competition or accelerator, if you like. It's a 6-month program. And so I volunteered and I've helped a lot of companies along the ways, young people getting started with their business ideas. And in 2014, I met Deepinder Singh. I was matched up with Deepinder for 75F. We won the grand prize. I fell in love with the company. And so 6-7 years later, here I am.
So just by kind of following something that matters to you, you made some choices along the way, and suddenly your paycheck is supporting your heart.
Exactly. And I feel like I'm working towards things that my kids and grandkids will benefit from.
So where do you think kind of this whole, I'm not talking specifically about 75F here, but where do you think this whole market is going in terms of buildings and energy efficiency and, the ability to reach in and start to wring out more efficiency in every building that we're occupying?
Yeah. So where it's going, there is a concept that's being discussed quite a bit now called a digital twin. This is where building data is brought online to the cloud for the purpose of modeling. And digital twins can encompass, all manner of data associated with a building. So the HVAC systems and the way that they're operating in the building management system that we have is a part of that. What we've done to be digital twin ready is our platform is built on Project Haystack, so that as soon as you light up a building that we're in, that Project Haystack tag data is now digital twin ready up in the cloud. And so that means that other people working on other systems like asset management and all these other dimensions that there are for a building, including its architectural features and its maintenance schedules and its support tickets and all those things that are associated with how a building operates can all be put into a online digital model. And that is where machine learning can be used for more than just what we're using it for, which is to optimize the energy use of the HVAC equipment, but it can be used to optimize virtually everything about that building. That's where it's going. And think of that as being like a building with a plug ready to plug into a smart city. So you have a smart building with a digital twin that can plug into a smart city. That's where it's going.
What I find fascinating about that is, I remember years and years and years ago, people were talking about the fact that we really needed smart thermostats and smart energy, but that buildings were inherently dumb. And there was this impatience that we were going to have to basically wait to rebuild every building and to focus on new buildings that hadn't been built in order to get to a point where you could get to what you just said. And 75F is essentially cutting that short and going, nope, your building's old, you have old systems, that's okay. We can reach into them, we can make it inherently more efficient as a result, which I think is fantastic. But I have a question for you.
Yes, sir.
You've been talking about buildings, and I'm going to guess you've been talking about big buildings. Most people think about the big buildings and the fact that these can be very complex, efficient kind of organisms that, as we've kind of described. Big buildings are only about 4% of the building stock. They're half the square footage, but they're about 4% of the building stock. The other 96% of buildings in the United States are small. They're 20,000 square feet. They're 30,000 square feet. They're a couple of stories. They're maybe 3 stories tall. How do you take this model that you're talking about and make it work for a dry cleaner? How do you make it work for a chain of restaurants? How do you make it work for a small office building?
Well, I'm glad you asked that question because essentially that is the problem that we set about to solve. Even though big buildings is where a lot of energy is being consumed, the rest of the stock, as you said, is underserved. So in order to reach that part of the market, we had to do a couple of key things. And these were basic tenets that we had as we started the design of the company to begin with. And the first was that it needed to be so easy to put in that a kid could do it. In fact, we even had a group of 6th graders put their own BMS in their own school just to prove that point. Not that I recommend doing it that way all the time, but it was just to make the point. So what we've done is we've created a completely out of the box ready BMS that makes it super accessible, right? And I mentioned earlier that we're not dependent on networking, right? We create our own network. So imagine going into a building, hooking it up to the HVAC equipment. All you have to do is turn it on and pick the type of equipment that it's running, and it's commissioned, and it's networked, and it's going up to the cloud, right? And so it doesn't require the traditional building, management system technician, those programmers that have ruled this industry up until now to get that done. So when it's out of the box ready like that, that makes it accessible. But the other key is to follow standards. Those are keys to scalability. So that's why we picked Project Haystack, for example, right? All of our data is homogeneous, following an open source global standard for IoT. We're not yet those tags where we're just using the Project Haystack tags. That means that anyone who's familiar with the Haystack tagging is instantly familiar with our data. No education needed because we're talking the same language. This is like raising the bar of interoperability to a new height. So following standards like Project Haystack and also ASHRAE, right? So like, for example, when you put us in a VAV system, even a 20, 50, 100,000 square foot building is probably going to have VAV. So we just follow the ASHRAE guideline 36 sequence of operation. It's canned, it's in the box. It's a standard. Those are the keys to gaining access to ever smaller buildings because the setup time and the uniqueness has been eliminated.
And I'll mention this, and I'm saying all this to give you a compliment. So I'm going to wind this up. You ready? So number one, the data about buildings and about the building stock in even a region of one state can be really hard to find. It's really bad. We're just not set up as a society to kind of track everything, right? Yet. And so this model that you're following, this digital twin kind of idea, is going to really increase the amount of data we have about what our building stock is and how it operates. But Prospect Silicon Valley did a study, and actually we got to know you through that study, under funding by the Department of Energy and working with the City of San Francisco and Lawrence Berkeley National Lab, looking at emerging technologies for small building stock. And we through a number of metric studies that are out there for the Pacific Northwest and the state of California and the U.S. Department of Energy and National Renewable Energy Lab, we kind of came upon this kind of statistic, and that is, if you take all these things and you make some kind of hand-wavy assumptions because the data is so bad, and you just look at the portion of the building stock that is both small and old. We're talking buildings that are 1990 vintage systems and such. Yeah. Which is more than people know is out there. There's a lot of old stuff out there.
Oh, yeah.
And you took just that portion of the building stock and you took just 10% of that portion, and those were the buildings that absorbed this kind of thinking or this kind of technology. And if those buildings got only a 10% increase in their efficiency, which is pretty nominal.
Yeah.
Nationally,
we can do that in our sleep.
Exactly. So if you took just that much, and that much of the building stock, that much of that sector, and only got 10% increase from those buildings, you're still talking about a net energy savings of $350 million a year. And we're talking at a cheap kilowatt hour price. So we're talking about a massive amount of energy that can be saved just by making old stuff more efficient. And that doesn't even cover the deferred maintenance and all the avoided costs because you're making things last longer, right? So what you're doing is literally avoiding waste and avoiding unnecessary cost and avoiding inflation.
That's very impressive. I'm really glad you brought that up, because we know that we're making a difference. And usually we think in terms of, if we're completely 100% rolled out and we're providing 20 or 30% efficiency, which is not uncommon for us. What would those numbers be? But what you've done is you've brought it down into a slice that's actually that can be visualized.
I learned that approach, by the way, and I'm going to bring this back to something we talked about earlier. I learned that approach from that very same particle physicist I mentioned. And if anybody hasn't figured out the name, it's Arthur Rosenfeld. He was a student of Enrico Fermi, worked at Lawrence Berkeley National Lab. I had a personal honor of sitting next to him in the office next door for a few years. So really? He's an amazing guy. But looking at these at scale and realizing the power of small things taken to scale can have huge results. And that's what you're chasing. And that's what we're really appreciative of. There was a question, and I want to get to some stuff kind of about Bob French in a second, but there was a question I wanted to bring it up. And that is, every building is kind of uniquely designed, unless it's a chain store, right? But most buildings, especially in their technical systems, are very bespoke, which means that we're constantly building prototypes. We're constantly taking grand adventures when it comes to building another building. How does that speak to your approach? Do you think that your approach feeds into this, or do you think that your approach could lead to a more standard approach to even very, very different buildings?
It's really a standard approach even to very different buildings, because we have thousands we've done and no two are alike. Even our chain stores that are supposedly alike, as we have done several chain rollouts, they're not actually alike. Once you look at the data models that come back from our machine learning analysis, you'll see that they really aren't different. They're oriented differently and so on. But to the point itself, when you break down HVAC equipment in this market, there really aren't that many different types. You have rooftop units that are packaged. And these rooftop units can be constant volume or variable volume. They could be staged or they could be fully modulating, right? And we understand the differences between those that sound subtle, but they're not subtle in terms of the way the equipment needs to operate. And they're typically connected either to no zone, meaning that they're a single zone, or they're zoned, and there's terminal units. They're VAV boxes. But VAV boxes, for example, what I mentioned earlier, the way the guideline 36 lays out the sequence of operation for those kinds of units. You have a VAV without reheat, you have VAV with reheat. The reheat can be hydronic, it could be electric, it could be two-stage, it could be SCR. It could have a fan, it could not have a fan, it could be a series fan, it could be a parallel fan. We've written profiles for all of them. So once you've figured out how to, what the sequence of operation is for the terminal units and the other terminal units too, like water source heat pumps, 2-pipe fan coil units, 4-pipe fan coil units, unit heaters, radiators, hydronic radiators, electric radiators, steam radiators, hot water radiators. I'm just rattling through all of the different types of terminal equipments that you'll find in, in commercial buildings. I guess if I use my toes and my fingers, I might actually be able to count up all the profiles that there are. It's not that many is my point. And so each building is different, and that the number of rooftops that are there are going to be different, and what zones that they serve are going to be different. But when you break it down into these elements of the different types of terminal units there are, and what kind of plant supply they're going to get, chill water, hot water, central air, or a fan coil, distributed air, those are all different ways to get it done. When you break it down into those elements, it's really just taking those elements and stacking them up differently, putting them together differently to essentially create a bespoke solution for each building, because it is bespoke, as you've said, except each block that we've created is not bespoke. You see? That's how we get that done.
That's really interesting. So ultimately you can start to teach designers how to design better buildings because you're able to operate them.
That is not uncommon, especially for our chain customers, where we start bringing data back into their portfolio of buildings. We show how, like for example, the sizing of a unit is either undersized or oversized. The duct, is either undersized or oversized. And we bring that information back to the engineer. We help them fine tune future designs.
That's interesting. So I'm going to ask you a Bob French question.
Okay.
Super unfair question. And man, I hope this goes well. What did you learn about cider making that changed how you approached your work?
Boy, that's out of the blue. So the thing about cider making is, as I said earlier, it goes on all year. It starts with the bud, right? I take a bud out of one stick and I put it in another stick because I've chosen the qualities of that tree that I want to, put into one of my future flavors. And then pruning that has to be done during the winter time. And then planting, in the springtime. And then in the summer, there'll be more pruning, selective pruning. And then of course, as mid to late summer goes on, we start harvesting the apples and making the juice and pitching the yeast and then conditioning this cider. And then of course, eventually enjoying it. That is a soup to nuts approach that I have found, and at my age, I now apply to the business. In other words, becoming familiar with how each and every aspect of the business operates, right? So that incremental improvements can be made in all phases.
You just taught us that the building stock is a grove of trees that is constantly producing something new and requires constant care and attention.
Love that, Doug.
That is amazing. Well, we are out of time. It's great to see you again. I'm glad that we could have this conversation. I hope that folks that joined us today learned something and were enriched by the experience. Is there anything you'd like to quickly plug or shout out? Yeah, there's links to my LinkedIn profile if you want to get in touch. Of course, you can come through our website if you want to look at our website is pretty thorough in terms of like doing research about us. And you can get us on Instagram and Twitter too. That's great. Thank you so much, Bob. I hope you have a wonderful rest of your day. Thanks you for spending time with us. I appreciate the opportunity. All right. You all take care.